clarification has been something else suggested as the theory of the old unlimited effect. Various evaluations, other than those made by a huge number of experts, support this thought, giving verification about how the universe began. In any event, the current universe of science, with new advancements, brings us novel evaluations and viewpoints. These assessments challenge our points of view, where certain bits of information, for example, those from Neil deGrasse Tyson, have transformed him into a massive figure in this ever-evolving universe of science. Now, something captivating is happening with the James Webb Space Telescope. It's crucial to note something that could make us question the theory of the universe's beginning. The James Webb Space Telescope has found 750 new galaxies. These systems are not exactly as expected, forcing us to reconsider what we thought we knew about them. This discovery should help us appreciate how massive galaxies became, so it's not surprising that it's reshaping how we understand the universe. Previously, scientists said that the Big Bang theory was an excellent explanation of how the universe began. According to this theory, around 13.8 billion years ago, the universe emerged through a perplexing event, like the cosmic story of its birth. However, the photographs from the James Webb Space Telescope have challenged this idea. These photographs show galaxies that are smaller, smoother, and older, seemingly different from what the theory predicts. According to the theory, as the universe expands, objects should appear larger the farther away they are. However, these newly observed galaxies seem to defy that rule. The theory also states that, at the universe's very beginning, all the matter that makes up the universe was compressed into a superdense point called a singularity. This singularity was unimaginably hotter than anything we can measure or replicate. This concept of a singularity arises from numerous equations in physics proposed by Albert Einstein, known as general relativity. Within the singularity, all the matter in the universe was packed into a tiny space with incredibly high density. It was an enormous amount of mass and energy condensed into a minuscule point. In simpler terms, experts have long stated that the Big Bang theory explained how the universe began. However, these new images from the James Webb Space Telescope are causing us to question that belief. The galaxies it discovered do not align with what the theory predicted, and the explanation of the early universe may not be as strong as we once thought. In our current understanding of the universe, all the energy in existence originated from a very hot and dense point called a singularity. This point serves as the starting point for everything we observe in the universe today. After this singularity, the universe began to expand and evolve over approximately 13.7 billion years to become what it is now. The expansion started with what many refer to as the Great Inflation, where the universe expanded unimaginably fast, much faster than the speed of light. During this period, the very fabric of space itself stretched, and everything within it expanded along with it. This massive inflation helped shape the universe by making it more uniform and creating conditions for galaxies, stars, and other cosmic structures to form. As the universe continued to evolve, it expanded at a slower rate than during the Great Inflation, but it still kept growing. This steady growth is called cosmic expansion. Experts have observed evidence of this expansion through phenomena like the redshift, which is the way light from distant galaxies shifts in color. Now, let's consider those stunning images of new galaxies taken by the James Webb Space Telescope. To most people, these photos appear breathtaking, showcasing diverse galaxies in a single frame. However, for scientists, these images come as a surprise because they do not align with theoretical predictions. First and foremost, these galaxies are much older than expected, challenging our understanding of the universe's origins. Viewpoint on framework construction and movement, as demonstrated by the speculation of the old-fashioned enormous detonation. There are other, altogether more egotistical systems than we expected. The speculation of the universe's beginning made deductions about the quantity of systems there ought to be and the way that they ought to be fanned out. However, the JWST pictures show a massive number of universes, a few more than anticipated. This makes experts question whether the speculation measures are precise. A couple of experts are, in any event, beginning to overcompensate a bit, considering the manner in which these disclosures do whatever it takes not to arrange their thoughts in any way. Another astounding piece of the new grandiloquent plans is their faultlessness, which conflicts with what the speculation of how things came to be proposed. As demonstrated by the speculation, universes ought to show irregularities and plans in their designs due to how they were outlined and developed. Anyway, photographs from the JWST show universes that are extremely smooth, without the normal intricacy and mercilessness. During the development of the universe, all that makes up our universe was fit into a small space. As the universe broadened and cooled, changes happened in particles like protons, neutrons, and electrons, which began to connect with light and energy around them. These coordinated efforts played a colossal part in the improvement of matter in the universe. In the initial few minutes after the Big Bang, there was a process called nucleosynthesis, which involved the development of lightweight parts like hydrogen and helium. These parts set the stage for the improvement of stars, multitudinous structures, and other complicated components as relentless history spread out. This blend of fundamental building blocks was a fundamental stage in the universe's improvement, progressing from a starting state of particles and energy to a state where matter began to form as expected. The speculation of the old Big Bang had anticipated seeing universes that were dispersed and violent. However, the JWST pictures tell an alternate story. Rather than stormy, dissipated universes, the photos reveal smooth, round, and spiral shapes resembling the systems we find in the contemporary universe. This disturbing revelation challenges the prospect that disarray is a typical piece of universe improvement. If there are few or no tempestuous events occurring in these universes, as proposed by the theory of how things came to be, it becomes unreasonable that tiny universes would have the option to develop into more immense. Similarly, the optical charming quality expected by the developing universe theory, where objects appear more unobtrusive with increasing distance due to expansion, doesn't seem to be accessible in space. Experts have observed a striking model where gigantic plans will regularly gather in huge get-togethers, forming different associations across the universe. This enormous structure lines up with the assumptions made by the theory of the universe's beginning. According to the theory, the universe began in an extremely hot and thick state, then expanded and cooled over time. As the universe expanded, gravity played a huge role in shaping how matter was distributed and in organizing systems. The gravitational effects expected by the speculation of the old Big Bang are consistent with what we see today, with gravity organizing matter, prompting the gathering of vast systems and the improvement of interconnected filamentary structures known as the cosmic web. The presence of these system groupings and the cosmic web structure strongly supports the theory of the old Big Bang. How systems are scattered across the universe aligns with the gravitational effects expected from a dense and expanding state, as proposed by the speculation. These elements, including the clustering of systems, the cosmic web structure, and the spreading of universal bundles, provide strong evidence that the universe began from an extremely dense state and has been expanding for billions of years. Now, we should return to the size of the plans observed by the JWST. These photos conflict with what we assumed we knew about the Big Bang theory. As shown by the speculation, little universes should form and loosen up through effects and combinations with different universes. However, the universes caused by the JWST feel very different from this idea. If grandiose plans were influencing and uniting as expected, we would see proof of these collisions or solidifications. Yet the photographs show something different. The Big Bang is still a relatively unproven hypothesis, basically an idea without concrete proof. However, it is genuinely supported by substantial evidence, including observations of the redshift of light and insights from distant universes, which offer support for the expanding universe theory. Studies showing universes growing in their distance from one another propose the normal constant expansion expected by the theory. The spread of light particles like hydrogen and helium seen throughout the universe is also consistent with the theory of the universe's beginning. Moreover, the grand distribution of universes, as revealed through cosmic diagrams, matches the models expected by the hypothesis of how things came to be. One of the primary pieces of evidence for the Big Bang speculation is the discovery of the cosmic microwave background, CMB. The CMB is weak radiation that fills the entire universe and represents the residual glow of the Big Bang. This radiation, first detected in 1965, still aligns with the estimates made by the theory of the universe's beginning. The observed characteristics of the CMB, its consistency and temperature distribution, strongly support the possibility that the universe was once in an exceptionally hot and dense state before undergoing expansion, a central part of the Big Bang theory. The discovery of the cosmic microwave background is an essential piece of evidence that gives us a unique view into the early moments of the universe. It serves as an echo of the primary stages after the Big Bang, assisting in confirming the extent of the universe's origin and development.